Bismillahirrahmanirrahim. Dear students, hope you will fine. This is class 10th, subject general science. Our today's topic is magnetic field due to a solenoid. First, we will discuss what is solenoid. The solenoid, it is a large coil. It is a long coil containing a large number of closed turns of insulated copper wire. Yes, a long coil containing large number of turns. It contains a large number of closed turns of insulated copper wire. This is a solenoid SN whose the two ends of this solenoid, they are connected to a battery B through a key K, through a switch S. When a current is passed through a solenoid, it produces a magnetic field around it, as shown in figure like this. The pattern of magnetic field lines produced by a current carrying solenoid is like this. The magnetic field produced by a current carrying solenoid is similar to the magnetic field produced by a bar magnet. You see, current carrying solenoid, yes, magnetic field lines या magnetic field produce करा, use magnetic field produce करा कुछ bar magnet. The magnetic field produced by a current carrying solenoid, it is similar to that of bar magnet, to the magnetic field produced by a bar magnet, to the bar magnet. The magnetic field lines produced by a current carrying solenoid, they pass through the solenoid, pass the solenoid and return to the other end. Pata se vata biggest ends. And return to the other end. The magnetic field lines inside the solenoid are in the uniform straight lines. The magnetic field lines solenoid straight lines. अमुक मतलब कि अत लगा यह पाई कि strength of magnetic field यह same at all points inside the solenoid. Then one we see the magnetic field lines inside the solenoid. They are in the form of the straight parallel straight lines. This indicates that you see strength of magnetic field, it is same at all points inside the solenoid. You see magnetic field inside a current carrying solenoid, it is uniform. Yes, it has a uniform magnetic field. You see magnetic field lines inside the current carrying solenoid, they are in the form of straight parallel lines. This indicates that the strength of magnetic field is same at all points inside the solenoid. Now, in other words, you see magnetic field, it is uniform inside the current carrying solenoid. Inside the current carrying solenoid. You see magnetic field inside the current carrying solenoid uniform represent by drawing parallel straight field lines. Agar it shows one end of the current carrying solenoid act like a north pole, while as the other act as a south pole. If a current carrying solenoid is suspended freely, it will come to rest pointing in the north-south direction. We have seen that solenoid consists of many closed turns. One end of the current in each turn of the current carrying solenoid, it flows in the same direction. Direction of current in the each turn of a current carrying solenoid, yes, same. Due to which magnetic field produced by each turn of the solenoid, it adds up, giving a strong magnetic field inside the solenoid. You see the strength of magnetic field inside a current carrying solenoid, it is very large, it is strong, it produces a strong magnetic field inside it. You see strength of magnetic field produced by a current carrying solenoid यह हसा depend करा दोन चीजन पे. It depends upon two things. One, it depends upon the number of turns in the solenoid. At mans kasa turns solenoid mans large, the number of turns inside the solenoid greater will be the magnetic field produced. Doim, it depends upon the strength of current in the solenoid. Mans kasa current paka. That means larger the current pass is zyada karo current pass through the solenoid, stronger will the magnetic field produce strong magnetic field. And it depends the strength of magnetic field produced by a current carrying solenoid. Yes, depend kara kim kusum material is istemal kara for making solenoid. This is all about the magnetic field produced due to a current carrying solenoid.